Some machines hit hard. Others shape with precision. This machine is doing two jobs in one line. The brush rollers scrub the potatoes and carrots first, so the surface is cleaner before cutting. Then the blades turn the roots into even strips, making them easier to cook, pack, or process in large batches. Soft bristles are harder to control than they look. The machine feeds each bundle into position and presses it into the broom base. By repeating the same motion with even spacing, it turns loose plastic fibers into a broom that can sweep evenly across the floor. A round steel tube does not have to stay round. As it passes through shaped rollers, controlled pressure slowly pushes the walls into flatter sides without cutting the tube open. By the end of the line, the same tube becomes a square profile used for frames, racks, and construction parts. A steel mesh is not always woven. The bars are crossed into a grid. Then welding heads press down at each contact point. Repeating that small joint across the whole panel turns loose steel bars into a rigid mesh used for reinforcement and construction. Hot steel looks almost alive under pressure. But it is not melting into shape. It is being guided before it has time to harden again. The press opens the center little by little, giving the metal space to move instead of tearing apart. Then the rollers take over, stretching that rough opening into a round steel ring. A spring is not powerful because it looks complex. It works because its spiral shape can take in force and give it back again. While the steel is still glowing, the machine bends one hot bar into that shape, turn by turn, until a straight piece becomes a working spring. This is not just about working fast. A tall bolt can turn a simple tightening job into a clearance problem. The skill is knowing when to use the proper socket and when to adapt with a strap or rope so the nut can still be tightened. Harvesting root crops is not just about digging them out. The machine lifts soil, vines, and potatoes together, then sends everything across a shaking bed. Loose dirt falls back into the field while the potatoes keep moving forward. That early separation is the real time saver, because the crop leaves the machine cleaner, lighter, and much easier to collect. A straight row does not happen by accident. Each seedling has to be placed at the right moment, at the right spacing, and with enough support to stay upright. This machine turns that careful hand rhythm into a planted, watered row in one pass. A clean crop row starts before anything is visible above the soil. The hard part is not just dropping seeds, but placing them at a steady rhythm and depth. Once each seed is metered, placed, and covered, the field is already being organized before the first shoots appear. Which process should we break down next? Up close, it is just one seed at a time. But repeated across every row, that small placement becomes the layout of the field. Straight spacing helps the crop emerge more evenly and makes the next machines easier to guide. A carrot is usually pulled by its leaves. This harvester uses the same idea, but repeats it across entire rows. It grips the tops, lifts the roots from the soil, and carries the carrots away before they ever pile up on the ground. Leafy vegetables cannot be washed like hard roots. The stems and leaves are soft, so too much friction can bruise them before they even reach the next step. That is why this line uses bubbles and moving water instead of heavy scrubbing. The first tank loosens the heavier dirt, while the second rinse helps wash away what is still clinging to the leaves. By the time the greens come out, they are cleaner and ready for the next step, draining or drying. Washing is not the final step. Wet leaves are harder to pack, and extra water can make them spoil faster. After the water drains through the mesh belt, airflow helps blow off the remaining moisture, so the greens move forward cleaner, drier, and ready for packing. What looks like messy dough becomes orderly in seconds. The mold gives every biscuit its shape and pattern, while the belt spaces them into clean rows. That consistency is what makes the next step possible. The biscuits are already baked and moving in the right direction. Now the machine has to prepare them for packing as a matched flow. It splits the biscuits into two streams, turns one side so the faces line up correctly, and brings them back together before wrapping. Once both streams meet in the right order, the film can fold, seal, and cut around each pack. Before a new coating can protect the steel, the weak surface has to come off first. Sandblasting removes rust, old paint, and loose scale by hitting the metal with abrasive particles. Once the surface is clean and rough enough, paint or zinc can bond to something solid instead of peeling away with the old layer. After sandblasting, the steel looks clean, but it is also exposed. Moisture and oxygen can start the rust cycle again. That is why the coating goes on next. Paint seals the prepared surface, while the rough texture from blasting helps it grip more firmly. This layer is not just color. It is what helps steel beams, tanks, and outdoor structures last longer in real use. This robot is built to work with 2 feeding lanes. When both sides are running, it picks parts from each stream and places them into the trays. But if one side stops, the robot can keep reading the active lane and adjust its path, so the line does not have to stop completely. Working on tall steel tanks is dirty and risky for people. This climbing robot takes over the exposed part by sticking to the wall and moving in controlled paths. First, it cleans the old surface. Then it sprays on a fresh protective coat. Layer by layer, the machine restores the tank's outer skin, helping protect the steel from rust and weather. Paint is not just for color. A steady spray gives the metal part an even coat, helping protect the surface while giving it a clean, finished look. We have seen a lot of transformations so far. Which one impressed you the most? Even in a fast line, human hands keep the parcels moving. This impeller is not shaped in one cut. Each blade is carved from solid metal, one precise pass at a time. Coolant keeps the tool stable, so the finished part can spin smoothly at high speed. These small parts are not shaped one step at a time by hand. A Swiss-type lathe feeds the bar forward while different tools cut, drill, and finish it in one cycle. That is how tiny precision parts are made quickly and consistently. A flat sheet can become a box without being cast or welded. Each bend locks one edge into shape until the panel becomes a finished metal tray. A blade would struggle with steel this thick. Here, the torch melts a narrow path through the plate, and high-pressure gas blows the molten metal out of the cut. Cutting the shape is only the first step. The flange still needs accurate bolt holes, so every part lines up when the assembly is bolted together. After metal parts, the process shifts to a softer material. This cutter follows the pattern and turns rubber sheet into usable strips or custom parts. Foam is too soft for many cutting tools. A heated wire follows the programmed shape, melting a clean path through the block without sawdust. Before any garment can be sewn, the fabric has to be cut into exact shapes. This automated cutter follows digital patterns, turning stacked cloth into matching pieces ready for sewing. One by one, the boxes enter a sleeve of film. Heat and pressure seal the wrapper. Then the machine cuts each pack free. In seconds, every box leaves clean, protected, and ready for sale. A pouch this small still has to be filled with precision. The machine opens the bag, holds it steady, and doses the liquid before sending it out. That keeps every sample, sauce pack, or small liquid pouch consistent from one piece to the next. It takes more than a simple fill to finish one jar. This line portions the contents, seals the top, adds the lid, and applies the label in one smooth flow. That is why automated packaging matters. Every jar leaves protected, consistent, and ready for the shelf. After factory lines, the process moves outside, where the product is no longer a small package, but an entire road surface. The truck keeps feeding hot asphalt into the paver, while the machine spreads the mix at a controlled width and thickness. Before the layer cools down, the roller follows behind and compacts it, turning loose asphalt into a smoother, stronger road. This machine has to work where the ground itself can slide. First, it climbs and positions on the steep slope. Then drills deep anchor holes into the hillside. Steel cables are placed inside and locked with grout, tying the loose outer layer back to stronger ground behind it. Rail tracks do not sit directly on the ground. The sleepers rest on crushed stone called ballast, which supports the track and helps spread the weight of passing trains. These vibrating tools pack the stones tightly underneath, keeping the rail line level, stable, and ready for heavy loads. After tamping, the ballast still needs to be shaped around the track. This attachment pulls loose stones away from the rails and pushes them back into a cleaner, more even bed. That leaves the track easier to inspect, better supported, and ready for the next train. Small concrete parts can be made in repeated molds. The machine fills each mold with the same mix. Then, the line carries them forward for handling. After they are lifted onto pallets, the parts are moved away to harden before use. After all the cutting and shaping, the final step is simple separation. Fine sand passes through the screen, while larger stones move to another outlet. Two clean outputs make a quiet ending.